Hello and welcome to Engineers Mindset Academy. So this is the third video on calculation involving work done in thermodynamics. And this particular question is actually a question from the 2022 thermodynamic examination past question from River State University, Port Harcourt, Nigeria. So let's go through the question. The question says, a certain fluid at 10 bar is contained in a cylinder with an initial volume of 0.05 meter cube. Determine the work done by the fluid when it expands reversibly according to the law P equals x all over V plus y all over V squared to a final volume of 0.1 meter cube and a final pressure of 1 bar where x and y are constants. Okay, so let's pick out the law. We are given law to be P equals x all over V, okay, plus y all over V squared. And again, they said determine the work done by the fluid when it expands reversibly. So by that sign convention, expand simply means that at the end of the calculation, we should have a positive work done. Okay, when it expands, it means we should have a positive work done. All right, expands reversibly according to this given law. Now let's pick out our parameters. At state 1, let's pick out the condition at state 1. Conditions at state 1. At state 1, a certain fluid at 10 bar, which means pressure P1 is equal to 10 bar, okay, is contained in a cylinder with an initial volume of 0.05. So which means V1 is equal to 0.05 meters cube. So these are the conditions at state 1. At state 2, let's pick out the condition at state 2. At state 2, it says determine the work done by the fluid when it expands reversibly according to the law to a final volume of 0.1 meter cube. So V2 is given as 0.1 meter cube and a final pressure of 1 bar. P2 is also given as 1 bar. Not forgetting, you always convert your pressure in bar to Pascal. So 10 bar simply means 10 by 10 to the power of 5 newtons per meter squared or Pascal, and 1 bar simply means 1 by 10 to the power of 5 newtons per meter squared. Always convert your pressures to Pascal. Okay, so these are the conditions at state 1 and at state 2. And I said when these conditions are given to you, the next thing is to find the value of P using, of course, the law given to you. In this case now, we need to find P is already given to be this, but we need to find what are the values of this constant before we can substitute into our formula. Remember, work done is equal to the integral from V1 to V2 of pressure times dV. This is our formula to calculate work done. Now we know pressure, but we cannot solve with pressure like this because x and y are constants and they are unknown. We need to find their values. So if this P or this law is true, then this simply implies that P1 is equal to x all over V1 plus y all over V1 squared. It also means that P2 is equal to x all over V2 plus y all over V2 all squared. That is what the law means. If P is equal to this and this law is true, then it means that the value properties of pressure at the initial state will be the properties of volume at the initial state. So P1 is equal to x over V1 plus y over V1 squared. Same thing as P2 will be equal to x over V2 plus y all over V2 all squared. So having known this now, we can now satisfy this law by plugging in the values from the conditions into the equation. So P1 was given as 10 bar, and 10 bar is 10 by 10 to the power of 5. So in place of P1, we have 10 by 10 to the power of 5 to be equal to x unknown all over V1. The initial volume at that case is what? 0.05. So we have all over 0.05 plus y also unknown all over V1 again, and V1 is 0.05 but now squared. So you have 0.05 all squared. You have this. Similarly, P2. So we call this equation x1 or star 1. Similarly, P2 is also the same, and P2 is 1 bar. 1 bar means 1 by 10 to the power of 5, and this is equal to x all over V2 as can be seen here. So you have x all over V2. V2 is given as 0.1. So this is x all over 0.1 plus y all over V2 squared. Okay, and V2 is also 0.1. Now you square. Call this equation x2. So let's write this now. 10 by 10 to the power of 5 can simply give you 10 to the power of 6. And this is equal to x all over 0.05 plus this is equal to y all over, let's obtain 0.05 squared. That gives us 0.0025. Okay, so call this equation star 3. Okay, whereas 1 by 10 to the power of 5 remains 10 to the power of 5 now from equation star 2. Okay, so this is now x all over 0.1 plus, now let's obtain 0.1 squared. Okay, so this gives you y all over 0.1 squared is 0.01. You can call this equation star 4. All right. So what I would prefer you to do at this point is recall that x over 0.05 can be written as x times 1 all over 0.05. This can be written as this. Okay, same thing as over here. X over 0.1 can be written as x into 1 all over 0.1. You can have something like this. So having that in mind, it means now that we can write these equations to be 10 to the power of 6 is now equal to, this is x into 1 all over 0.05, okay, plus same thing here. You can also factor y. It becomes y into 1 all over 0.0025. Call this equation star 5. All right, and over here 10 to the power of 5 becomes 10 to the power of 5 is equal to, also you factor x from here, this becomes x into 1 all over 0.1 plus y into 1 all over 0.01. Call this equation star 6, and you have this. Now the reason why we did this is so we can be able to break the equation down in simpler terms to solve. Now we can find 1 all over 0.05. So 1 divided 0.05. Okay, let's start from equation star 5. You have 10 to the power of 6 is equal to 1 divided 0.05 gives us 20. 20 times x gives us 20x. Okay, plus 1 divided by 0.0025 gives us 1 divided 0.0025 gives us 400. So 400 multiplied by y gives us 400y. You can simply call this equation 1. Okay. Then from equation star 6, you have 10 to the power of 5 is equal to 1 divided 0.1. 1 divided 0.1 simply gives us 10. 10 times x gives us 10x. Okay, plus 1 divided 0.01 gives us 100. 100 times y gives us 100y. You can simply call this equation 2. So you have two simple simultaneous equations to solve, and now it becomes very easier for us to solve. I always tell my students the best way to solve simultaneous equation, especially under an exam condition, because this was an exam question. So under an exam condition is by employing the elimination method. Now, how do you eliminate? Simply, you pick out a term you want to eliminate. Let's say I want to eliminate x and find y. If I want to eliminate x and find y in this equation, what I will do is in equation 1, pick out the coefficient of x in equation 2, use that value to multiply the whole of equation 1. Then pick out the coefficient of x in equation 1, use that value to multiply the whole of x, the whole of equation 2. So if I want to eliminate x now, the coefficient of x in equation 2 is 10 because it is 10x. So I will simply use 10 to multiply the whole equation 1, whereas the coefficient of x in equation 1 is 20. So I'll simply use 20 to multiply the whole equation 2. That will help me to what? Eliminate x. So you simply say multiply equation 1 by 10 and equation 2 by 20. So you're simply multiplying the whole of equation 2 by the coefficient of x in equation 1, which is 20, and you're multiplying the whole of equation 1 by the coefficient of x, which is in equation 2, which is 10. So by so doing, you're going to have, this is 10 to the power of 6 equals 20x plus 400y. Okay, the whole of this multiplied by 10, which is the coefficient of x in equation 2. Again, for equation 2, we have 10 to the power of 5, which is equal to 10x plus 100y. Now you're multiplying this equation by the coefficient of x in equation 1, which is 20. So this is now times 20. And you have this. So if you carry out this multiplication, you're going to find out that 10 times 10 to the power of 6 will obviously give us 10 to the power of 7. And this is equal to 10 times 20x will give us 200x plus 10 times 400y will give us 4000y. Okay, so you can call this now equation 3. Also, 20 times 10 to the power of 5 will give us 20 by 10 to the power of 5, or simply 2 by 10 to the power of 6. And this is equal to 20 times 10 will give us 20 times 10x will give us 200x plus 20 times 100y will give us 2000y. Call this equation 4. So it becomes easier now. You can now subtract equation 3 from equation 4. Simply append a minus sign there. Subtract equation 3 from equation 4, or you can subtract equation 4 from equation 3. Whichever you choose is the same thing. All right. Okay, so we are subtracting. So we are subtracting equation 4 from equation 3. We are going to be subtracting equation 4 from equation 3. So we simply have 10 to the power of 7 minus 20 by 10 to the power of 5. Okay, 10 to the power of 7 minus 20 by 10 to the power of 5. And this is equal to, again, 200 minus 200x. 200x minus 200x plus, and finally we have 4000y minus 2000y. Okay, 4000y minus 2000y. All right, so we simply have this. So let's now obtain 10 to the power of 7 minus 20 by 10 to the power of 5. That simply gives us 8 by 10 to the power of 6. And this is equal to 200x minus 200x is off, that's 0. Then we have 4000y minus 2000y, which simply gives us 2000y. So from here, we can be able to find the value of y. So you see that we have now been able to what? Eliminate x. So from here, we can find the value of y by dividing through with the coefficient of y, which is 2000. So this simply implies that y is equal to 8 by 10 to the power of 6 divides 2000. And therefore, y is equal to, let's obtain that division, divide by 2000. Y is equal to 4000. Okay, so this is the value of y, 4000. Now, if you know y, you can simply substitute into any of the equations, say equation 2 or equation 1, any of them at all, and you can find the value of x. But let's go with equation 2. Let's put in the value of y into equation 2. Substitute into equation 2. And if you do that, from equation 2, we have 10 to the power of 5. 10 to the power of 5 to be equal to, we have 10x here, 10x plus, we have here 100y. So plus 100 in place of y, y is 4000. So it becomes 100 times 4000. Okay, so 10 to the power of 5 is equal to 10x plus 100 times 4,000 gives us 400,000. Okay, you have this. So to make x subject, first of all, we transfer plus 400,000 over to this side of the equation. So we have 10 to the power of 5 minus 400,000. Okay, so this is equal to 10x. So let's obtain 10 to the power of 5 minus 400,000. That gives us minus 3 by 10 to the power of 5 to be equal to 10x. Okay, so in order to make x subject, we divide both sides by 10, and therefore x is equal to minus 3 by 10 to the power of 5 all over 10, which simply implies that x is equal to minus 30,000. Okay, x is simply minus 30,000. So if we know the value of y and we know the value of x, then we can rewrite simply our law. The law can now be rewritten. Remember the law? P is equal to x all over v plus y all over v squared. This is the law. So this simply implies that the law is now P equal to what is x? X is minus 30,000. So you have minus 30,000 all over v, okay, plus y. And what is y? Y is 4,000. So plus 4,000 all over v squared. This becomes now the law. So this is what we are going to be imputing into the equation for work done to find the value of our work done. Okay, so we can start our calculation now. Okay, so the law becomes now, P is equal to, so we can rearrange this. This is negative. Let's start with the positive one. 4,000 over v squared minus 30,000 all over v. So this becomes the law. All right, so let's start the calculation for work done. So you recall work done is equal to integral from v1 to v2 of p dv. So this is equal to integral. What is our v1? Initial volume was given as 0.05. So you state it out from 0.05 to final volume V2, and V2 was given as 0.1. So to 0.1 of P, this is our pressure, 4,000 all over V squared minus 30,000, okay, all over V all times dV. All right. So you can simply expand with integral sign. The integral of a difference is simply the difference of the integral. That simply means you can expand by the integral sign. So this multiplies this, gives us integral from 0.05 to 0.1 of the first, which is 4,000 all over v squared, minus the integral again. This multiplied by this becomes integral from 0.05 to 0.01. That is the law of integration. The integral of a difference is simply the difference of the integral. Okay, so you have multiplied by 30,000 all over v, not forgetting times dv times dv. And from the rule of integration, constants always come out of the integral sign. So we'll pull out 4,000 and we pull out 30,000 from the integral sign. So this is simply equal to 4,000 comes out. This is 4,000 integral from 0.05 to 0.1. This now becomes 1 all over v squared times dv minus, same thing here, pull out 30,000. So I have 30,000 integral from 0.05 to 0.1 of 1 all over v times dv. All right, so not forgetting 1 all over v squared. Since v here is to the power of 2, it means we can write this by indices. 1 all over v squared automatically becomes v to the power of minus 2 by indices. But keep this in mind, please. Do not go and write 1 all over v to be equal to v to the power of 1 while integrating. If you do this, you're already getting it wrong, because if you integrate v to the power of minus 1, you're going to have, from the rule of integration, add 1 to the power, divide by this new power, now it becomes minus 1 plus 1, and this will be v to the power of minus 1 plus 1 is 0, all over minus 1 plus 1 is also 0, and you have 1 divided by infinity, and you have 1 divided by 0 because v to the power of 0 is 1. So this will simply give you 1 all over 0, and 1 over 0 is infinity. So this rule is only applicable when the power beneath the denominator is greater than 1. Then you can convert this to what? V to the power of minus, converting this to bar. But under an integral condition, when the power beneath the denominator is not more than 1, then you leave it like this and continue your integration. All right, so we are going to now rewrite that integral. So this simply becomes equal to 4,000 integral from 0.05 to 0.1. This now becomes v to the power of minus 2 dv minus, okay, here we have 30,000, okay, integral from 0.05, 0.1, keep it as 1 all over v dv. Now you integrate. From the rule of integration, we have 4,000. If I integrate v to the power of minus 2, the rule simply says add 1 to the power, so minus 2 plus 1. Divide by this new power you have now, which is minus 2 plus 1. Put in your limit from 0.05 to 0.1. So from 0.05 to 0.1 minus again 30,000. Now, if I integrate 1 over v, I will simply have a natural logarithm of v. So this will give me ln v. So you put in your limit from 0.05 to 0.1 and you have this. Okay, so the work done is now equal to 4,000 into v to the power of minus 2 plus 1. Minus 2 plus 1 simply gives us minus 1. So you have v to the power of minus 1 all over, same thing here, minus 2 plus 1 also gives us minus 1. So all over minus 1. Okay, limit is from 0.05 to 0.1 minus 30,000. All right, ln v, put in from 0.05 to 0.1. Okay, so from here, of course, you can factor out this minus 1. 4,000 divided minus 1 becomes minus 4,000. So the work done is now equal to minus 4,000 into v to the power of minus 1 from 0.05 to 0.1 minus 30,000, okay, into ln v from 0.05 to 0.1. So I'm trying to do everything together so that I'll put the limits at the same time. Now, from indices, once more, v to the power of minus 1 simply means 1 all over v. We already know this from indices. V to the power of minus 1 is simply 1 all over v. So I like to always solve my problems like this instead of solving with to the power of minus 1. So I will simply break it down like this. So therefore, this is now equal to minus 4,000 into, in place of v to the power of minus 1, we simply have 1 all over v from 0.05 to 0.1 minus 30,000 into ln v from 0.05 to 0.1. Okay, so from here now, we can put in the limit of the integration. Remember, upper limit comes first minus lower limit. So wherever you see v, you put in upper limit minus lower limit. Now, this is equal to minus 4,000 into, this is 1 all over v. In place of v, I start with upper limit. So this is 1 all over, upper limit is 0.1. So 1 over 0.1 minus, again, lower limit, 1 all over 0.05 for the lower limit, okay? Minus 30,000 into, this is, okay, again, upper limit minus lower limit. So I have ln, in place of v, start with the upper limit, which is 0.1. Ln 0.1 minus ln lower limit is 0.05. So 0.05, we have this. Okay, so this is equal to minus 4,000 into 1 divided 0.1 will give you 10. Okay, minus 1 divided 0.05 will simply give you 20. You have this. So minus 30,000 into, now mind you, over here, you can simply look for lane 0.1 minus lane 0.05. So, okay, let's just do it at once. Lane 0.1 minus lane 0.05. That simply gives us 0.69. Okay, lane 0.1 minus lane 0.05 approximately gives us 0.69. All right, so another way to go around this is by simply saying, since we have lane 0.1 minus lane 0.05, from the rule of logarithm, you have two numbers subtracting, two logarithm of a number subtracting one another. By the rule of logarithm, you simply pick one of the logs and divide their number. So this becomes lane 0.1 divides 0.05. And 0.1 divided 0.05 will give you 2. So it simply means lane 2, and you will still have the same value, 0.69. Anyone you wish to go about it, you will get the same result. Okay, so from here, work done is equal to minus 4,000 into 10 minus 20 gives us minus 10 minus 30,000. Okay, let's multiply this at once. 30,000 multiplied 0.69. 30,000 multiplied 0.69 gives us 20,700. Okay, so from here now we have that work done is equal to minus 4,000 multiplies minus 10, minus times minus is plus, 4,000 times 10 gives us 40,000 minus 20,700. So this simply implies that the work done is equal to 40,000 minus 20,700. That simply gives us 19,300 joules. So this becomes the work done, 19,300 joules, or you can actually approximate it to be 19.3 kilojoules. So that's the value of the work done. Now let's fall back to the question again. Question says determine the work done by the fluid when it expands. Once again, I've said expansion simply means the work done must automatically be positive. So when a system expands, it means that system gains heat, and if it gains heat, it increases in size. That is expansion. Work done in that case is positive because work is being done by the system on the surrounding. Okay, but if the condition says compression, then automatically you're supposed to have a negative result for an answer. All right, so that is why we are having the work done here, and the other videos we've done so far, the values to be what? Positive. All right, guys, I'm sure you like this video. I'm sure you find it interesting. Please do well to express that by clicking on the like button, share this video to your friends, and also share your thoughts in the comment section. And if you're new to the channel, please and please, I would encourage you to, of course, subscribe, and of course, to subscribe, because it gives me motivation to always want to do more for you guys. Thank you very much, guys. I will see you in the next video. Thanks and cheers.